Hello everyone, let me talk about deep copying and assignment. In this video there will be less amount of coding. Most of the time I will be actually explaining the things. In particular I will be explaining how deep copying and deep assignment work. For that purpose I will be beginning with this code. First let me explain this code. We have a class with the attribute number and the name, where the name is to be stored in dynamic memory space. Default constructor, we have this custom constructor to receive number and name and copy that data into this attributes. We have print function to display the data, and destructor to actually release or destroy or release the dynamic memory space in which the name would be written. And we have main function with the command to create an object with the data, and command to execute the print function, and within the block scope there is another object created and print function invoked, and outside the block there is another object created. So it will be the base. I will make some changes here. This is going to be the base code from which I actually want to start beginning to explain deep copying and deep assignment. So to explain it better, first let me quickly talk about the memory space, the way the object of this student class would be stored in the memory. For example, if I create S1 with the data 1001 and name Harry, and it will actually allocate memory space to hold integer 4 byte, and memory space to hold this name, which has 1 2 3 4 5 characters plus 1 null character, 6 characters memory space in dynamic memory space. But it will actually allocate this amount of memory space that is required to store pointer in the static memory space. So the thing is that if I actually want to create a new object, let's say this S3, by copying from S1, in that case copy with deep, something called deep copying is involved. In this case, but we have not defined a logic for this, so it will fail. There could be problem while running this code, but the idea is that you have this S1 object with this information is stored in the depth, in the dynamic, we call the dynamic memory space as a memory in the deep level. So the data is stored in the depth. You want to copy this from this object to this object. That's the reason why we call this as deep copying, right? And but at the same time, if you have let's say another object already created S0, and if you want to actually assign S0 equals to S3, so in this case you are actually unlike in the previous case where the new object was created by copying from the existing object, in this case the existing object is actually copied to another object. So therefore the thing that happens underlying things that happen here is a little bit different than what happens here and what happens here. So I actually will explain what actually happens in these two cases. In this case something called deep assignment is involved, right? So to explain it, I'm not using the terminal because I'm not compiling and running this code, but just I want to explain. Therefore I'm switching to this space here. Let me first start with I want to choose a text, maybe Arial. if I create a student with data 101 and name Harry, and if I, let's say, I create another student object S2 by copying from S1, right? In this case, if for example, if I have this name is stored in static memory like this, in this case what happens here is you will have a memory. Let me draw the lines that actually mark the memory space. I think this 3 lines should be sufficient. So let me remove this part. Now assume that this is memory space. I mean, it starts from the first byte, second byte, and goes, and after that it continues from here, right? So this, I assume that we didn't have a space to, I mean, put all this string in the same line. Therefore, I have put in different line. But you have to assume that it immediately starts from here, right? It's just this memory address actually comes immediately after this one, something like this. Now, in this case, this statement will create an object, and the way of creating object is allocating memory space for this data, and it will actually have a memory space created to store, let's say, one integer 4 bytes. Suppose this is 4 byte memory space, and it will have a memory space to hold I mean, memory space of size 64 bytes to store for that 64 byte character that I showed you just before. It's going to be 64 bytes, and out of this 64 bytes, only 6 bytes are used to store this these characters HARRY and null character here, right? And if I this will be the this object S1 with data 1001 here, and this is a null character. So Harry. So we have this they store this data object in this way. If I create a new object by copying, then it will this statement will allocate a new memory space for this S2. So it is going to be something like this. Suppose it gets a space here, so the space to store ID and another memory space for 64 byte characters, and first it will allocate a space and it will initialize data. That means this will actually should initialize the data copying from this place. So that means what happens here is it should actually copy all these bits from this place to this place, and it will copy all these bits to this place. So it should copy all the data. That means this new object will have same data stored. This is something called shallow copy, right? We call this static memory space as a shallow level. Let me mark this by a different color. So you can call this entire thing as a shallow. Any copying that happens in from one place in this memory to another place is called shallow copy. Let me write it here. make it black. So this is any copy that happens from one place to in this memory space to another space is allocable one more time. Now in the case where we have this pointer variable instead of this static array, in this case the data would be actually stored not here. I mean, let me just go back to the previous state of this diagram. I'm going to be just removing. In that case, static memory, this memory space for ID will be in the static memory, but another member is pointer. So it will not allocate 64 bytes. It will only allocate the memory space that is required to hold the address, which is 8 byte. So this amount of memory space will be allocated for this object, and internally when you actually create the memory space using this new command, in this new command in that at that time it will actually have a deep memory access to deep memory space. Let me just mark it by, suppose this is the deep memory space, then it will have that the memory space which is sufficient to hold that name would be allocated in this deep space, and this address of this memory is actually copied in this place, which is indirect way of saying that this is actually pointing to this deep memory space. So this holds the address, and like before you have 1001 stored here, and in this place it will be address, and obviously it is in the form of bits, 1010 form, and this space will actually get the data. Right. So this is how it is actually stored. Right. So now this is how this entire data is stored. Whenever you try to access this, and you actually access the address of this name, and then it goes in this memory space, reads, and then it displays the name. In this case, if you want to copy this thing, then you would have similarly you will have a memory space allocated for the ID, and another memory space for the address. Now if you copy, I mean, if this thing actually copies all the things, all the bits from this space to this space, then actually it will be copying 1001 here, and it will be copying that address, same address, right. So I mean, in effect it will be actually there will have two pointers pointing to the same memory space, right. So this object, the pointer member, will be pointing to this memory space, this object pointer member pointing to this memory space, which is not desired, right. There could be issues, we want to avoid that. We want to have this object to have its own dynamic memory space storing its data. So we want to avoid that. So what actually we copy operation, deep copying, therefore we need to implement deep copying operation. And when you say deep copying, then what it means is, when this object is created, the memory space for ID and the address is actually created or allocated, and during this copy operation, the amount of memory space that is required to store this data is actually calculated, and same amount of memory space is actually created in this space in some other place. It could be in before this memory, it could be after this memory, wherever it is available. And after that you make this address point to this pointer point to this memory space. Then after that you do copying this thing, this data, because that is from static copying. Now in the case of deep copying, you actually copy in the deep space. This is a shallow space, this is deep space. So you are copying this character by character. Right. So you copy character by character, and the result is you will have copy of that data stored here. So this copying is called deep copying. Let me write it here. And this sort of copying is called shallow copying. This particular copying from this copying of this ID is our number is shallow copying. So I hope it helped you to understand the difference between shallow copying and deep copying. So one more time, the copying that happens in the dynamic memory space from one place to another place is deep copying. The copying that happens in the static memory space from one place to another place is shallow copying. Now I'm going to be talking another term, which is deep assignment. We have two terms to discuss. One is deep copying, and another term here is deep assignment. Okay, so to explain deep assignment, I think I need to remove this thing, this part. So let me remove it. So we have a situation where we already have another object, let's say student S3, and let's say its ID is 3003, and then this is the name. Right. So I have this S1 object. Suppose assume that this we don't have this thing here, and we have another object here. So we have this one object with the thing in the dynamic memory space. This pointer would be pointing to this place, and this space is holding the data 1G01. And at the same time you have another object. Suppose this object is gets memory space in this place, and this space for the pointer, and it will have this data 3003 KMBERLY. No, I think this is a little bit problem. So let me explain it further. So I will just come back and talk about this in a moment. Okay, so this is not this thing is not stored here because I told you before. So let me erase it. So this is actually holding the address of this memory space, and we'll have another memory space to store the data called Kimberly, and this will hold an address of this Kimberly object. So this is actually holding pointing to this data and is pointing to this data. So we have this situation here. We have this object with name stored in dynamic memory space S1. This is S3. And if we actually have a statement like this here, let's say 3 equals to S1. So this statement actually copies the data from one object to already existing object. So if you just do this kind of copying, then what will happen is it will actually you create a new memory space for this to store this data, and you make this pointer point to that data, and if you want to make this pointer point to another, then you need to actually automatically this is going to be deleted because this memory space is overwritten by the new address. So this was the dynamic memory space that was created, which will exist if it is not deleted properly, and this new memory space will have the data Harry written in it. So first what you need to do when you want to and this process is called copy assignment. If you are copying from existing object to another object, that is copy assignment. And what happens here is that first you actually you can copy this. Copying this data is actually shallow copying ID number. So you will be actually copying 101 here. That is going to be shallow copy. Now in this case you are doing deep copying, but essentially when you are doing everything, you need to detach it, you need to release this memory, you need to detach it, and then you need to perform deep copying. That entire process is called deep assignment. Okay. And once this assignment is completed, then you actually have this new object having the same ID, and it has its own dynamic memory space containing the same data as the previous object. And two three things you need to be keep in mind when you are doing a deep assignment. One, you don't want to copy from same object. You don't want to copy from the same object itself. For example, if you do S1 is equal to S1 or S3 equals to S3, that is copying to the same object. You don't want to do that. And you want to release the memory associated with the object. You release the dynamic memory associated with the object being copied to. If you don't release, it will lead to memory leak problem, and if you don't do this, then you will be copying unnecessarily executing the code to itself. So you will be making your code inefficient. Thank you for watching. In the next videos I will explain how to implement this copy operation, this copying, deep copying and deep assignment, how to have a code to actually properly perform the deep copying and deep assignment. Thank you.